Okay, we're going to talk about the equality properties of real numbers. And the first one is the addition property. If A equals B, then A plus C equals B plus C. Then we have the subtraction property. If A equals B, then A minus C equals B minus C. Multiplication property, if A equals B, then A times C equals B times C. And the division property, if A equals B and C is not equal to 0, then A divided by C equals B divided by C. Next we have the reflexive property, which is just that A equals A. So one thing equals itself. If it were 10, then 10 would equal 10. 15x would equal 15x. Then we have the symmetric property, which is if A equals B, then B equals A. So we can just flip-flop the two. The transitive property is if A equals B and B equals C, well then A must equal C. So it's like the law of syllogism. The substitution property says that if A equals B, then A may be replaced by B in any equation or expression. So we can swap out A and B in any equation or expression. If we have that A is equal to B and A is 5, well then B is also 5. And for any A's or B's in the equation, I can put in 5. And then we have the distributive property. And to get that, obviously, we have to distribute. So we distribute the A to both the B and the C, and we would get AB plus AC. Now we are going to use the properties that we just talked about to prove algebraic equations. So when we're doing this, we're going to do it in a two-column proof format, which means we have a column for statements and we have a column for reasons. And the statements is the algebra side of it, and then the reasons, we're using the properties that we just talked about to say why each of these statements is true. So we have our given and our prove. Our given is what they've given us, and prove is what we're proving to be true. So we're given that 6x plus 2 times x minus 1 equals 30, and we need to prove that x equals 4. So the first thing we always start out with is the given, and that's the equation we were given, and our reason is that it was given. And now we need to figure out, well, what was this next step? How did we jump from here to here? Well, we distributed the 2 to the x and the negative 1 and got 6x plus 2x minus 2 equals 30. So now we've got to figure out the reason for that, which property it was. Well, we had to distribute, so that would be because of the distributive property. So that's what we would write as our reason. Now we need to figure out how we're going from here to here. Well, what would my next step be? Would be combining these like terms. I'm going to combine 6x and 2x to get 8x. And when we combine like terms, we are using the substitution property. So 6x plus 2x is equal to 8x, so we can replace this with just 8x, so substitution property. Now we need to figure out how we get from here to here. Well, our next step would be to add 2 to both sides. And how is that true? The addition property. We added. If we add 2 to both sides, we get 8x equals 32. Now how do we get from that to x equals 4? Well, we would divide by 8 on both sides, which is the division property because we're dividing. And the last part is our answer, what we were needing to prove. That's how we know we're done. And how did we get that x is equal to 4? Well, that would be substitution. We can substitute x with 4. So that would be the substitution property again. And like I said, we know we're done because this is what we were asked to prove, so we're done with our proof. Now we're going to try another one. This time we're given that 5x plus 1 divided by 2 minus 8 equals 0, and we need to prove that x equals 3. So just like on the other one, we have to start with what we were given, which is the equation 5x plus 1 divided by 2 minus 8 equals 0, and our reason is given. So now we've got to figure out the next step. So what do? Well, we need to add 8 to both sides. If we add 8 to both sides, we'll get that 5x plus 1 divided by 2 equals 8. And how were we able to do that? Well, that was with the addition property, since we added. So that would be our reason. The next thing we would need to do is get rid of this dividing by 2. The inverse operation of division is multiplication, so we will multiply by 2. And what we do to one side, we have to do to the other. When we do that, these will divide out. So we will have 5x plus 1 equals, and then 8 times 2 is 16. We multiplied, so our reason would be the multiplication property. Then we need to subtract 1 from both sides. So all we're doing is just solving this equation. And when we do that, we'll get that 5x equals 15. We subtracted, so our reason would be the subtraction property. Then we'd need to divide by 5 on both sides. So those would divide that out, and we would be left with x equals 3, which is what we were trying to prove. Since we're saying that x equals a number, that's using the substitution property, since we would be substituting 3 for x. Oh, and we divided by 5 first, so that would be the division property. And then getting that x is 3 would be the substitution property, and we would be done, since we got what they asked us to prove. Now we're going to go over the algebraic properties in geometry. So it's just like the properties of real numbers that we talked about up here, and we're just applying it to segments and angles. So it's the exact same thing. We already talked about reflexive, symmetric, and transitive, but we're applying it specifically to segments and angles. So reflexive is that AB equals AB. That segment equals itself. And same thing with angles. The measure of angle 1 is equal to the measure of angle 1. Then we have symmetric. So we can flip-flop the equations. Basically, if segment AB is equal to the measure of segment CD, well, then we could say CD equals AB as well. They can be flip-flopped. Same for angles. If the measure of angle 1 equals the measure of angle 2, well then, the measure of angle 2 is equal to the measure of angle 1. So we can flip the left and right side of the equations. And then lastly, we have the transitive property. And for segments, that's AB equals CD and CD equals EF. Well then, AB must equal EF, just like the law of syllogism says. Same thing for angles. If the measure of angle 1 is equal to the measure of angle 2, and the measure of angle 2 is equal to the measure of angle 3, well then, the measure of angle 1 must equal the measure of angle 3. So just like the law of syllogism, we get rid of the middleman, and we're left with the first and last. Now we're going to use these to do some geometric proofs. Again, we have a given statement and a proof statement, and they also gave us a picture, and we're going to do this in the 2-column proof format. So we've got to have our statements, and then we're going to give our reasons of why those statements are true. So we have that the measure of angle 1 is equal to the measure of angle 2. So the measure of angle 1 right here is equal to the measure of angle 2. And then we have that the measure of angle 2 is equal to the measure of angle 3. So we also have that these are equal. They want us to prove that 1 and 3 are equal as well. So we start out with what we're given. Well, we're given that the measure of angle 1 is equal to the measure of angle 2, so that's given. We were also given that the measure of angle 2 is equal to the measure of angle 3 right here. So this one would be given as well. And that last step would be saying that the measure of angle 1 is equal to the measure of angle 3, which is what we wanted. And we know that that's true because of the transitive property. Or, like we've talked about previously, the law of syllogism. Since this is what we were asked to prove, we know we're done with that 2-column proof. And we can move on and try another one. This is just wanting to know what property justifies each statement. So they're giving us if-then statements. So if this is true, prove this. And we're just going to write what property could be used to prove that this is true. So first we have that if the measure of angle 1 equals the measure of angle 2, well then the measure of angle 2 is equal to the measure of angle 1. So which property talks about just flipping the left and right sides of the equation? That would be the symmetric property. Next we have if the measure of angle 1 equals 90 and the measure of angle 2 equals the measure of angle 1, well then the measure of angle 2 must also be 90. So basically what we can do here is substitute this 90 in for the measure of angle 1 since we know those are equal, and we would have that the measure of angle 2 equals 90. So that would be using the substitution property. Number 3, if AB equals RS and RS equals WY, then AB must equal WY. So what we did here was we cut out the middleman and we're left with what we had first and last. So that would be the transitive property, just like the law of syllogism. Number 4, if AB equals CD, then half of AB equals half of CD. And this would be the multiplication property. Because all we're doing is taking what we originally had and multiplying both sides by the same number. Hence the multiplication property.